Let us see about riverman problem. Okay. Let us consider a swimmer who can swim in the still water with velocity v. That is, velocity of man is v, and the river is flowing with velocity of u. It is the velocity of river, that is u. Let the swimmer start swimming from point A, and he is swimming at an angle theta with the direction of flow. So here we have considered he is swimming in this direction and this is the direction of flow, so this is theta. And now we have to talk about the effective velocity of swimmer. If this is the direction of his velocity and this is the angle made by the swimmer with the horizontal or with the flow, then we can resolve it into components. This is v, this is v cos theta, and this is v sin theta. So if this is velocity v, this is v cos theta, and this is v sin theta. So effective velocity of swimmer along the flow is in this direction is u plus v cos theta. Similarly, perpendicular to the flow is only v sin theta. Now let us consider two more cases to cross the river in minimum time. Next is to cross the river in minimum distance. So first let us discuss about a minimum time. Okay. To cross the distance in minimum time, he should go perpendicular to the flow. If flow is like this, then he should make his velocity in this direction, so that he will be drifted, so he will be going like this, he will be drifted, going like this, drifted, going like this, drifted, going like this, drifted. Finally, he will be placed somewhere here. In C, he will be placed. So, let us see. Time t is equals to width by velocity, that is distance by time. This is the distance, that is b, width of the river. What is the velocity? V sin theta. Why we are taking v sin theta? Because we have to take the component of velocity in the direction of motion. So he is going in this direction, so we have to take that particular component, so that is v sin theta. We want t to be minimum because he wants to cross in minimum time, so t to be minimum, sin theta should be maximum. So if sin theta should be maximum, then theta should be equals to 90. So t is equals to b by v, sin theta is 1, b by v. Now, from this very well we can see theta equals to 90 degree. That is what I have told initially. He should make his direction perpendicular to the flow. Now, what is BC? This is called as drift. He will be placed somewhere here. So, he aimed at here, but he is drifted by the river and he is placed here. What is that drift? Okay, let us see. That is BC. So it is this in this direction, horizontal direction is drift. Okay. Now for horizontal direction, we have to take the components of velocity in the horizontal direction. And what is that velocity? We have already seen, that is u plus v cos theta into time. Okay. So u plus v cos, we have already seen theta equals to 90 degree, v cos 90 into t. So v cos 90, that term is 0, so it is just ut, that is u into b by v, because time is equals to b by v, that we have already seen. Okay, now we can see his velocity is like this, v, and the river velocity, river's velocity is like this, that is u. So what will be the resultant velocity? They both are perpendicular to each other. So according to the vector laws of addition, we can say it is under root u square plus v square, and its direction is along AC. That is, if there are two vectors like this, then the resultant will be like this according to parallelogram law. So that is equal to u square under root u square plus v square along AC. Now let us see what if the swimmer wants to cross in minimum distance. So minimum distance, if he is wishing to cross, then his angle should be obtuse with the flow. If he is starting like this, then again he will be drifted, again he will be drifted, he will be drifted, he will be drifted, he will be drifted, and he will be placed here. So this is the minimum distance. Okay, so to make minimum distance, he should make an obtuse angle with the flow. So we have already seen if this is v, this will be v sin theta, this will be v cos theta, and this is u, that is direct velocity of river, and v is velocity of man. Okay, u plus v cos theta is along the flow, v sin theta is perpendicular to the flow. Now here he is placed finally here, so his velocity was only in this direction, that is along the flow his velocity was 0 because there is no drift. If there is some drift, then we can say there is some velocity along flow, but he has started here and finally he is placed here, so there was only one velocity, that is v sin theta, that is the total velocity. So we can say u plus v cos theta equals to 0 because along the flow there was no velocity. And see, cos theta equals to minus u by v. Theta equals to cos inverse minus u by v. This is one important result we are obtaining from this. Now let us see what is the resultant velocity along AB. So his resultant velocity finally was in only one direction, that is AB, that is equals to v sin theta. So v sin theta we are writing, we know sin square theta plus cos square theta equals to 1. So sin theta equals to root over 1 minus cos square theta. V into under root 1 minus cos square theta, I am writing it as u square by v square because I have written cos theta equals to minus u by v. So cos square theta equals to u square by v square. So this we can write under root v square minus u square, and this is the resultant velocity along AB. So along AB his velocity is, his resultant velocity is under root v square minus u square. This result can be kept in mind. Now what is the time of crossing? Time of crossing we know it is b by v sin theta, we have already seen because it is the direction of motion and we have to take the velocity in the direction of motion. So b by v sin theta was the time. So that is b by under root v square minus u square. So time of crossing is b by v sin theta. Here we have already derived v sin theta equals to under root v square minus u square, that we are writing here, b by under root v square minus u square. This result also we should keep in mind.